am Priya, the Assistant Professor of BSH. Today we are going to discuss the topic, the differential equation. The differential equation's topic is the D operator method. This is the D operator method's topic. The topic name is D operator method. Now we solve the given equation. The given equation can be written as d square minus 5d plus 6 times of y, and here x square e to the power 3x. At first we solve the differential equation by using the D operator method. At first let us take y equal to e to the power mx not equal to 0, m not equal to 0, because here m is equals to 0, the equation becomes y equal to e to the power 0, that means y equal to 1. The y equal to 1 here is not exist, so let y equal to e to the power mx, where m not equal to 0, we have trial solution. Of the given equation. In our question, and this equation gives the number 1 here, the number 1. The auxiliary equation becomes here we put in y equal to e to the power mx. Now at first the differential equation dy dx is equals to m e to the power mx, dy by dx is equals to m e to the power mx, and also again differential equation d2y by dx is equals to m square e to the power mx, m square e to the power mx. So here we put all the differentiate in the given equation 1, and the auxiliary equation becomes m square minus 5m plus 6 is equals to 0. Here we solve the factorization m minus 3 times m minus 2. So our values of m is equals to 3, 2. Here we know that in the differential equation m is equals to 3, 2. So our constant is arbitrary constant is we take C1 and C2. So the complementary function becomes the complementary function. What is complementary function? Complementary function is that y is equals to C1 e to the power alpha x plus C2 e to the power beta x, where C1 and C2, are arbitrary constants. This is the complementary function, and here alpha is 3 and beta is 2. So these are the constants. So we put the values C1 e to the power 3x, C1 e to the power 3x plus C2 e to the power 2x. This is the complementary function. But let at first here right hand side is x square e to the power 3x. So our general solution, we solve this differential equation by D operator method, we get the general solution. So we will get the general solution after we find the particular integral here. So the particular integral is of the form d square minus 5d plus 6, and here v x square e to the power we know the formula is of differential equation 1 by d square minus alpha d plus beta times e to the power mx sum v, where v is the function of x. V is the function of x. Here the formula becomes here e to the power mx exponential function and times function of x. So we solve this particular integral. E to the power mx in front we written 1 by d plus m that square minus alpha times d plus m plus beta times v. Since f of d is equals to 0, so d is equals to m, we know that f of d is equals to 0, but in lower denominator it should be 0. So the particular integral is undefined. So we put d is equals to d plus m. Then f of d not equal to 0, and we solve the particular integral. As we proceed in this equation, 1 by d plus 3 square minus 5 d plus 3 plus 6 times x square, and here e to the power x, the 3x here given, and then we solve this particular integral. D square plus 9 plus 6d minus 5d plus minus 15. Minus 15 plus 6. Here we cancel out 15 and here x square even. 3x 1 by d square plus d. After calculation is denominator. Then we common 1 by d. So 1 plus d x square, and here e to the power 3x 1 by d times, and this here 1 plus d to the power minus 1 times x square. Here we apply the binomial expansion. So we get 1 minus d minus d square minus etc. x square. So we apply x square, and here at first differentiate 2x, and here x. Here second differentiation of x square is 2 x square dx square, that means minus 2x d square x square 2 times again differentiate minus 2. So here e to the power 3x x cube by 3 minus integration 2 x square by 2 minus 2x. Here e to the power 3x x by 3 minus x square minus 2x. So this is the particular integral here. So we solve, we get the complementary function and the particular integral both. So the general solution is y is equals to cf, that means complementary function, plus pf. So cf is c1 to the 3x plus C2 e to the power 2x plus Pi is e to the power 3x x cubed by 3 minus x square minus 2x. Where C1, C2 are arbitrary constants. First we tell that where C1 and C2 are arbitrary constants. So our discussion, our result is that, and in this process we solve the D operator method, and the result becomes the general solution y is equals to complementary function and particular integral.